welcome everybody to week 5, day 1, arguably day 2 because it's a Wednesday. So we got a lot of learning points to talk about today. And first is going to be the times table. I guess we should probably even put that up here. The times table assignment. Times table assignment. Yep. And let's pull up the grading over here. Y'all did pretty well. I think. Yeah. All right. So overall, not bad. The times table assignment. What did you find to be the trickiest part on the times table assignment? Forming a table, everything lined up properly, headers, yeah. I mean, I gave you guys the code to do sort of the inner part of the thing. So we are going to, I'm just going to solve it from scratch right now, and I'll show you kind of the step-by-step approach I would take to solving it, because there is a way of going about solving problems that you kind of need to get, and that's to do as little as possible that does something, okay? So, for example, you might start off by reading the min and max. For those of you that don't know the read function, this is essentially the same thing as writing int min equals 0, cn into min, and cn up in here. Please enter the starting number. Basically, it does these three things, but it also does error handling. So you can't use it on this homework assignment, because for this homework assignment, you need to handle errors and print bad input and stuff like that. Mine will silently discard it and reprompt. So later on, you're more than welcome to use the readlib to make your inputting easier. But for now, I want you to do it the slow and bad way that is part of the core library. Because read is not part of the standard library, right? That is something I made. So you're not going to see that anywhere else. Nested for loops, yeah. The point of the assignment was to teach you about loops and putting loops and loops in front of loops and loops beside loops inside of loops. So to get those brain circuits exercising. And I should mention that I am going to open up the Zybooks for extra credit. If you do all of the loop section extra credit, I especially recommend this for people who are dicey, not 100% on loops. The Zybooks, I only gave a little bit of it because I try not to really overwhelm you with work. I really try not to. But sometimes people just need more work. So I'm going to make this an extra credit opportunity. Section 4 loops. I did move the Zybooks back a couple days to give you a little more time on the functions section. So that's due on Sunday at midnight now. That's an unusual deadline for this class. Don't expect it to be the same in future classes. So Zybooks, if you're not doing the Zybooks, it's going to hamper your computer science knowledge. I have a guy in this class whose sister I had a couple years ago, and she was like, "Yo, you need to be doing the Zybooks." He's like, "I know computer science." No, do the Zybooks. So it's really important to run through them. And so there's a lot of labs in here. I only had you guys do the first 4 or so, something like that. So if you want to do all of the labs, I will give you extra credit. So if you failed the times table assignment, this will make up your times table assignment. Take up to 5 if you do all of them. And if you already got a 5, I'll give you extra credit. So it's a lot of work. The main thing I want to emphasize here is to not cheat. All of these things are available online. You can simply highlight any of these things here, right click, hit search DuckDuckGo, and Chegg will pop up as the first answer and has a worked solution for you. So then there's Course Hero and other cheating websites as well. I am a fairly tolerant professor. One of the very, very few things that really, really pisses me off is when students just copy and paste answers from Chegg and Coursera and things like that, because you're not learning. My number one goal is to get you all to learn. I want to take all of this knowledge of computer science and just like pack it into your brains. Like that's my goal, is just to have you coming out of my class able to write a program. And if you just copy and paste programs from Chegg or Coursera, you're not learning anything. You're not learning anything. And so it's also really obvious when people do it, because your answer is from Chegg, and I have a Chegg account and can check it. And Zybooks is a built-in cheat detection system as well. So if you're planning on running through all these labs by just copying and pasting the answers from everywhere, please don't. Just don't do it. Right? Just like eat the 5 points. It's not a big deal. Timestable is a half-point assignment. It's half a normal number assignment. Just give up. That said, if you don't know loops, please do this. Please go through it. You have to get branches and you have to get loops down pat. Like, you have to get them. If you don't, the rest of the semester is going to be a train wreck, because everything uses loops and everything uses branches and everything uses functions and variables. Can you imagine trying to go through algebra not knowing what a function is in algebra? Like, oh Lord. Or going through algebra like, you know what, I don't know variables. I'm just going to put my head down and just try and get a C. No, it's a train wreck. If you don't know what a variable is, it's going to be a train wreck. You have to know these basic things. Like, there's plenty of details you don't need to know. Like C++ is full of all sorts of weird, trivia and things like that. You don't need to know those. But variables, input and output, branches, loops, and functions, those are the bread and butter. Those are the most important things in all of computer science. You have to get them down. And you have to know how to do a nested for loop, and you have to know the function stuff that I'm going to teach today. And you have to know what a variable is and how to set a variable and convert between different variable types. Like if you don't know that, go through the Zybooks and do it. I know you're able to click through these things here, you just show answer. Are you sure? Yeah, show answer. Show answer. Okay, it's 5. It's 1. By the way, I can see when you guys do this, and whatever. That's not cheating. I don't care. If you want to cheat yourself out of an education, go for it. I will be slightly judgy, but I'm not going to say you're cheating if you do that. You're only hurting yourself if you don't read the material. That said, for the labs, if you copy and paste an assignment do you have to complete all the labs? Yes, all of them. That's the extra credit assignment. It's a challenge, a lot of work. It's a lot of work. It is. That's why I didn't give it to you all. So there you go. And if you copy any of them from Chegg, it's a black stain on your morality. So don't do it. It's just really annoying, because you have a bunch of students all turn in the same answer that's from Chegg, character for character, and sometimes people try and change a variable name or change the spacing. It's like, no, I can see all of that. The cheat detection system picks up all that, so just don't do it. The threshold for copying is 1 line of code is fine to copy, because when you look at the reference material, it'll give you example functions, right? Like if you want to see how to sort a bunch of numbers. We haven't gone to having a bunch of numbers yet, but if you want to learn how to sort them, you can come down here and you can see, okay, that's how you sort a bunch of numbers. You can copy and paste that. It's fine. Not a big deal. That's what professional programmers do. We look at examples of how functions are called and we copy and paste them in and modify them to our needs. It's fine. If you ever find yourself copying and pasting more than 1 line of code, then that's cheating. Okay, and you're probably going to run afoul of the cheat detection system, and it's going to be a hassle. I hate doing paperwork. It's just annoying. So just please don't. If you're going to be copying and pasting, just don't do the extra credit. It's fine. 5 points isn't the worst thing in the greater scheme of things. Okay. You have 1 week to do this. Okay, so you have a week to do all of the labs, and that will grind into your brain loops. It'll grind it into your brain. Learning is all about grinding. You have to repeat, you have to practice, you have to read and write and think about things until it's ingrained into your brain. If you don't do that and you have sort of a loose notion of what a branch is or a loop is or whatever, like you're just going to train wreck. And maybe you don't do the whole thing, maybe you just do a couple of them to get more practice. That's fine. I also recommend doing that for branches. Like if you're still kind of dicey on branches, there's plenty of labs for the branches that I didn't assign either. Go back and do some of those. Get more practice in. You know? So, yeah. So don't, don't kill yourself if you got other work to do. It's only 5 points. But I'm making this opportunity available to the students that like didn't get loops and didn't get the question right. And we're moving on to functions now. We're about to do the competency exam for loops too, so it'd be a good opportunity for you to both practice for the competency exams and recover some points if you didn't do the times table assignment. Or if you did the times table assignment, get more practice in, get more points. Okay. I need practice and extra credit. Yeah. So I offer lots of extra credit. And the extra credit's always more work usually than just doing the thing. Sometimes extra credit is just like, come to listen to me talk about Irish music, I'm going to play a Bull of Vogue, you're going to like it. Okay. So that is that. So Zybook's extra credit, times table assignment. Yes, let me code this up for you guys. So if not cn die, this, by the way, is a function I have to write here. Cout bad input. So this won't happen, by the way, because I'm using the readlib, but you should have something like that in your code. If min is greater than max, you're supposed to die. And then if max minus min is greater than max size, die. So max size is defined to be constant. Max size to be 20. So that is how big the times table can be. At most, you can have 20 rows and columns. And if you go over it, then it won't work. So, common problem a lot of students had was A, they didn't check this. You need to see if min is greater than max. That's an easy pickup of a point. Shamelessly plug in the TC to come for help. Crente got your back in the TC. Yeah, Crente just posted the TC schedule too when different Seaside tutors are available. And so, for all of these things, you need to start early, and if you get stuck, ask for help. That's the computer science way, for success at least. If you wait to the last minute, it's too late to get help. So you need to get help early. And if you're like loose on like a fundamental concept like branches or something, make an appointment with Crente and actually sit down, or Mincarelli, and sit down and actually just go over it. Okay. So what's the problem here? What's the problem with this code? So if the starting number is 1, the ending number is 20. Okay, cool. If the starting number is 0 and the ending number is 20, that should not be cool. Why? The maximum table size, and by the way, a lot of people did this instead. They said if max is greater than max size die, this is bad. Okay? And it's bad because you can have a times table going from 30 to 40. That's a times table going from 30 to 40. That's fine. Just the size of the table can't be bigger than 20. Okay? 0 to 20 is 21 digits. That's correct. This is called a fence post error. And so my code should be dying, but it's not. This is called a fence post or off by 1 error. It is probably the most common logic error in computer science, where you do something like, all right, I started work on the 10th, I ended work on the 30th, therefore I worked 20 days. Is that right? If I started work on the 10th and ended work on the 30th, 30th was my last day, did I work 20 days? 30 minus 10 is 20. Yeah, you got to include the 10th. So it's 21. And so if you take 20 minus 0, that's actually 21 days. So you need to slap in a greater than or equal to there. And that handles the case of 0 to 20, bad input. That's one of the edge cases you have to check for. That's why I give a ton of test cases, because I test all these different edge cases where you can slice that off by 1 and catch some students with it. Okay. So yeah, if I was born in 77 and died in 78, I died, well, it depends if it's before or after my birthday. Let's say on my birthday. I was 1 year old. 78 minus 77 is 1, right? But I was alive in 2 different years, 77 and 78. So you have to be very careful with those off by 1. They're called fence post errors, because if you have 2 fences, you have 3 fence posts, right? If you have 2 fencing sections, there's 1, 2, 3 fence posts. And it's very common for people to buy like 10 fencing sections and 10 fence posts, or even worse, 10 fencing sections and 20 fence posts. But if you're going to buy 10 sections of fence, you need 11 fence posts, because yeah. So very, very common error, very, very common mistake in computer science. If you, yeah, and some people go the other way, like 19, which is a normal mistake. We go, well, like, all right, we need to like subtract 1, or something, right? And that's pretty common too. And they, there's an off by 1 error, but then you go off by 1 in the opposite direction, right? So, yeah, there's a famous joke in computer science that there's only 3 intractable problems in computer science. The first, naming variables. The second, off by 1 errors. I'm waiting for the laughter on the Discord channel. There we go. Thank you. Yeah, Crenty had to hear that in the last lecture as well. It is though a famous joke in computer science, and it does kind of drive home the point quite well. 1 + 1 = 3. Yeah. Okay. So yeah, thanks. My TAs laughed at least. No more extra credit for any of you. Okay, so we got all that. Once we get all that set up, then we need to actually do the assignment. So phase 1 of me writing the times table assignment was getting the input and the error handling and all that stuff working correctly. Phase 2 was getting the meat of the table, the inner part of the table, the actual times table working. And then phase 3 was putting the row and column headers on, which is where most people had trouble with it. So it's like stream lag during the joke. No, my timing, it's all off. Okay, so yeah, so let's start off by doing just the meat of the table. This is the code I gave y'all last week. Ooh, the internet. What happened? What happened, Mr. Internet? Somebody hammering the server? Nope. Okay. Okay, so anyhow, let's do this for int I equals min. I is less than or equal to max I++. Again, this does not follow the standard pattern that I teach you guys. This is one of the, like I say, like 95% of the time, you're going to say for int I equals 0, I is less than blah, I++. That's the pattern, and blah is how many times the loop runs. This is one of the few cases where I would say, yeah, don't follow that pattern. Just start at min, go up to max, up to and including max. It's more readable that way. And now let me show you another problem. Out I times j with a tab. Anyone see what the problem is? Anyone catch it? Too late. Compile. Run from 1 to 20. Infinite loop. Control C. There we go. So why is there an infinite loop? Uh-oh, major lag. Why is there an infinite loop here? Yes. Yes, very good. I copy paste error. Copy paste errors are the third most common source of bugs. Okay. So I copied and pasted this loop, I changed the j here, I changed j here, I did not change the j here. So this loop will never end because j never gets bigger. So I need to change I. It's lagging again. Oh. Something going on? Network transmissions. OBS Studio, Discord is running. Wallpaper engine's running. Oh, Carbonite. It's backing up my computer right now. Cool. All right, let's turn that off. Backing up is cool, except when it happens in the middle of class. Pause my backup. Let's pause for an hour. There we go. All right, is that better? Is it streaming better for you guys now? I'm lagging a bit. Yeah, my automatic backup kicked on. Thanks. All right, cool. All right, sorry about that. So, yeah, you can. All of a sudden, like, I start pixelating. Yeah. Okay, so anyway, so copy paste errors are the devil, right? So every time I copy and paste something, I have this moment, like I do this YYP, let's indent it, and then I just slowly go like this. I'm like, I know every time you copy paste something, you got to change something, right? So I slowly go through it, and change all the I's to the J's. That is habit born from long, outstanding practice of having bugs. Okay, so there we go, and then we will compile the code and run it from 1 to 10, and there we got. What the hell happened here? We forgot to do a return. Okay, so we're printing everything out on one line, and so at the end of every line, this is one line of the times table. We're now going to need to throw down an inline. Now it's formatted properly. Cool. So phase 2 is now complete. All right. So now we need to add headers on it. All right. So we need to add the top left part, which is going to say we're doing a times table. I'm not going to do the plus table. It's more or less exactly the same. So before we do all this, we're going to see out a times with an X with a dash T after it. So that's going to be the top left part, and then every time you echo something, the cursor moves to the right on the same row. It keeps going to the right until you hit enter, end line, and then it goes to the next row. So we're now going to need our column headers. So this is just going to be YY and P. This is just going to be the same numbers here. See out I followed by a tab character. And then once we print out that whole row up top, we are going to hit return. And then we can run it from 1 to 10, and you can see we've got our column headers are in place. We just need the row headers now. See, everything's shifted left because we don't have row headers, and so this part here is our column headers, and now we're going to need our row headers. So before every row, we just need to see out what row it is, followed by the tab character. In the previous class, they asked what's the difference between a single quote and a double quote. Double quote can hold multiple characters. This is the X character followed by the tab character. This, even though it looks like 2 characters, it's 1. Backslash T is actually interpreted as this, as the tab character. So you can actually enter the tab character if you're a Unix wizard. Most people aren't, and so they just do backslash T instead. And so this is a string. Double quote can hold more than 1 character. It's a string. It holds multiple letters. So it's an X followed by the tab character. You can't do this with a single quote. Single quote only can hold single characters, and bad things will happen if you try doing that. You can, however, do this if you want. Because strings can hold single letters, it's fine. You just do that. And so I do know that some students will just like always use double quotes and never use single quotes, and that'll work up to a certain extent until you need to pass a character to something, then it won't work anymore. So get to know the difference between single quotes and double quotes. There's probably a small performance gain to doing this instead of this, but our CPUs are fast enough. You're not going to notice any speed difference. Okay, so I think we're done. We got this, and 1 to 10, and there we go. So that's times table. That's our homework assignment. Okay, so done. All right, so that was the whole thing. All right, so times table's been taken care of. Cheating's bad. Zybook's extra credit's been handled. I guess we're working our way up from the bottom. Now let's talk about the top here. So let's talk about functions. So today's a function day. Did my headers a little differently. Cool to see it done in a different way. Yeah, there's lots of ways of doing your code, but you can see the whole implementation, like the whole thing. 22 to 42, about 20 lines of code. This will probably expand out a little more. It's about 30 lines of code. Okay, so let's talk about functions. So all the functions we've talked about so far have been like algebra. All the functions we've talked about so far have been like algebraic functions, like int f of x, return int x, int y, return x squared minus 10 times x times y plus 3 times y squared, something like that. And so this would be, in algebra terms, f of xy is equal to x squared minus 10xy plus 3y squared, something like that, right? So it takes in an input or multiple inputs and returns a value. You guys down with this? Like, you understand? If I were to give you this in algebra, you should be able to give me this in C++, or actually the whole thing in C++. Do you think you could do that? Like, if I asked you to translate some algebra into C++, do you think you could do it? Maybe with some sines and cosines and abs's and fabs's and things like that. Yeah. Okay. Yeah, that's always kind of the easiest way of understanding functions, which is why I start with it, because we all know what functions are from algebra, and it's just sort of a good conceptual starting point to think of them that way. However, learning point for today is that not all functions are the equivalent of algebraic functions. So down here I could do something like this, c out of f of 10, 10. It's going to print out negative 600. I haven't done the math, but I assume it's correct. So 100, I don't know, 100 and 300 minus 1,000, negative 600. Yeah, it sounds right. Okay, so a function, the way that a function works is your code always starts here. Your code starts running here, right? Like, that's a down pointing arrow, like down here. Right, this is the first line. First line of the program that runs is the first line of main. And when you get to a function call, main pauses, and then it jumps up into the function call, runs the function, and then it returns back into main. Maybe. If you have an exit, it never comes back into main. It just quits. Right, but most of the time you call a function, it does some stuff, then it comes back. And then main keeps running, and then maybe it calls another function, and it jumps up there and starts running, and then it jumps back to main. Okay. So we can do things like int x is equal to f of 0, 2, like that. So we can either see out the result of a function, or store it in a variable, or we can do other things with it. Anywhere an integer can exist, we could pass it. Like if we wanted to be really crazy, we could see out f of 0, 0, 0. Is that right? And 1. We really want to do it that way. So it passes the result of f as the x parameter to another f. And yeah, you can have a function, call a function, call a function. It's pretty normal, really. Okay. But what we're going to talk about first here are functions that do not return a value. This is a this function does not return a value. Void. Okay. G and let's see, hello world and x. So this function will not return a value. So what does that mean? I'll show you in a second. Well, why would you have a function if it doesn't return a value? And that's where algebra and computer science differ. In computer science, you can have a function have a side effect. You can have it do something other than just returning a value. In this case, we're going to echo hello world to the screen. This function will echo hello world to the screen x times. Okay. So should we use, we're passing an x and we want to print out hello world x times. Should we use a for loop, or should we use a while loop, or should we use a range-based for loop, or should we use a do while loop? What loop should we use if we know how many times we're going to print hello world? And we know it because it's passed into us. X is how many times we are going to output hello world. What do you think? That is correct. It is a for loop. So for int I equals 0, I is less than blah, in this case x, I plus plus. So this means x times do the following. That's the English equivalent of a for loop, right? X times do the following. And this is the pattern. This pattern should be engraved, or should in the future be engraved into your brain. This is the pattern we use over and over and over again in computer science to do something x times. Okay. So inside of the for loop, we're just going to see out hello world. The sad thing is the world never says hello back. And then what if we try to return 0? Can't. What void means is this function does not return a value. So you cannot return a value. If you try returning a value, it's a compilation error. You can just type return if you like. It makes you happy. You don't have to. You can just leave it like that. And then down here, we can say, what's going to give us a positive value? 1. Let's see here. If we do 3 and 0, then that's going to return 9. Okay. So we will call helloer, passing an x. And by the way, we don't have to name this variable here the same variable there. It's just a coincidence. They're the same thing. We call this one retval if we want. That's retval then. Say okay. Or if we wanted, we could just do this. Like that. That works. Same thing. Okay, so this is going to print hello world 9 times if my algebra skills are up to task. 6, 7, 8, 9. Good. Okay, so this function here computes the f of 3, 0, which is 9. That's 9 minus 0 plus 0, 9. Okay, and then we pass in 9 to helloer. Main pauses, it jumps up here. X is set to be 9. It says for int I equals 0, I is less than 9, I plus plus, see out hello world. So it's going to see out hello world 9 times. Okay, doesn't return a value. You can do a return statement if you want to bail out early. For example, if x is greater than if x is greater than 10, we could do something like this, like say, see out, sorry, that's just too many hellos. Right, and so you can do that, and then if they try, and that's actually fairly common, like if you're going to be printing like 900 things, like, you know, just cut it off, x is over 40. Yeah. And so if we come in here and do 5, that should be 25 hello worlds. There we go. But if we pass in 10, it'll be 100 hello worlds. And then it just says, sorry, that's too many hellos. So if you do a return from a void function, it's not returning a value, it just quits out of the function. And then it comes back down here and keeps going. Okay. It doesn't quit the program. Like a lot of people think return means quit the program. It just means return from the function. So if I put it down here, goodbye. Then you see that return doesn't quit the program. It just returns from the function. So it comes up there, says sorry, too many hellos, then it prints goodbye. So when you run that command, it jumps up here, sees that x is equal to 100, 100 is greater than 40, prints that, and then returns. And when it returns, it comes back and runs the next line of code. Okay, so that is a function that does not return a value. What if I tried doing this? What if I tried saying cout helloer? Okay, the compiler might be a giveaway. What happens if I try couting a function that doesn't return a value? What happens if I try couting a value that doesn't exist? What do you think? It will not compile. Void is not 0. Void does not exist. You can't see out the result of a void function. Okay. You cannot say int x equals helloer, right? Void is not a variable type. It means there is no value there. There's nothing there to catch. Okay. So let's demonstrate a function that takes no parameters and returns nothing. This function takes no parameters, so it's very not algebra world anymore, right? It takes nothing in, returns nothing, but it's got side effects, so it's okay. So this function takes no parameters in and returns nothing. You can think of it as like a saved block of code you can reuse. So if you have the same chunk of code, like if you've got 5 lines of code that you're using over and over again in your source code, it's often a thing to put them into a function. And then you just call the function every time rather than copy paste 50 lines of code, copy paste 50 lines of code, copy paste 50 lines of code. No, you just take those 50 lines of code, stick them up into a function, call it, and then every time those, instead of retyping those 50 lines of code or copy pasting 50 lines of code, you just call the function. And so we're going to call this function something. Somebody give me a name. Names are always the hardest thing for me. Give me a function name. Yoda. All right. So in the previous class, they asked me to compute the Pythagorean theorem. So this function takes no parameters in. You'll see some people write void there to indicate there's no parameters. That's kind of old school. We don't really do it. If there's nothing in the parameter list, there's nothing in the parameter list. No parameters are passed in. Nothing's returned back. But every time you call Yoda down here, it's going to run all of the code up here. So I can do something like cout space rocket ship galaxy. Cout do or do not. There's no try. Right, and so every time it runs the Yoda function, it prints these 2 lines of text. I don't know if that's text exactly. Something. Okay. How did I do that with the characters? I used the force on the keyboard. I used force on the keyboard to enter the things. The force surrounds us all. So Windows key period pulls up the emoji keyboard, and then you can have like a cat riding a dinosaur or something like that. And then every time Yoda gets called, it does cat and a dinosaur and a meteor and a spaceship and things like that. And so imagine that I had, I don't know, there's like, I don't know, all these different things, and I'm not gonna bother. Oops, too much, too aggressive. Excuse me. So we got like all these lines of code here. Every time we call Yoda, it's going to do those lines of code. Okay. So rather than having to copy and paste those lines of code over and over again and copy and paste over and over again, it's just like, nah, we'll just put it up into a function called Yoda, and we're just going to do those 6 lines of code. Thank you. Over and over again. So you can see here, it's like that, and then it does 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 that. So over and over again, we can just keep reusing this block of code, and we can put anything up in here. So in the previous class, they asked me to show the Pythagorean theorem, and so we can do something like this. Float A, so read, please enter the first float. And float B. Please enter the second float. And then we want to see out the Hypot of A and B is square root of pow A squared plus pow B squared, square rooted, end line. Okay, so now every time we call Yoda, it will come up here. It'll ask us to type in an A, type in a B, output what the hypotenuse of A and B is, the length of the hypotenuse. And this will happen 1, 2, 3 times. Okay, and the reason why this is nice is because it puts, like, copy pasting code is like, we all do it, but it's dangerous. And the reason why it's dangerous is like, what if there's an error in your code? Right, now you've copied and pasted that error in the code. 3 and 4, the Hypot is 5. 30, 40, the Hypot's 50. 100, Hypot's 141.2 or 42. So you can see it keeps doing that Hypot calculation over and over again. So this is better than read is like CN. Yeah, read is my custom thing. So I could have like copied and pasted this thing like over and over like this. But no, like as a computer science major, your instinct should be, if you're copying and pasting the same block of code over and over again in your code base, make it a function. That should be like what you immediately like, we need to pull this out into a function, because let's say that you find a bug in it, right? Like let's say that rather than doing an addition here or something, you did a subtraction. Now you've got 50 copies of this thing all over the place, and you got to Control F for the plus sign or something, I don't know. And you like got to go through all 50 cases and fix all of them, and you forget one of them, and that bug lingers in the code, and then one day you launch your rocket and it turns sideways and blows up. It's much better to put it all in one place, so that if you have a bug like this, you can just go, oh, that's a bug, you fix it. Now it's fixed. Down here when it calls Yoda, and down here when it calls Yoda, or down here when it calls Yoda, it's fixed in all 3 of those places. Or, even better, if there is a faster implementation, like rather than doing all of this stuff, I can actually call the Hypot. Hypot of A and B. Boom. That's a standard library. That's part of the CMath. Good. So, Hypot is a standard library function, and it's probably faster than doing the square root and the pow. Okay. So, yeah, the read function is here. It's in /public/read, and it is just a better way of doing CN. And your homework assignments probably won't allow you to use these, at least for a while, and I do that deliberately because you will not get used to how horrible CN is. Because it's really bad. Like the way that C++ does input by and output by default is kind of garbage. It's kind of garbage how it works. CN and getLine don't work with each other, and so yeah. If you use my read lib at the beginning, you'll become spoiled by how good it works. and not want to learn how CN works. And then you'll go to a job interview and be like, oh, this is how I'll do input. And they're like, what's this read function? That doesn't exist. So you need to get used to using CN. I hate using CN because readlib is just better. So anyway, so Hypot is the standard library function that computes the Pythagorean theorem. Put in 3 and 4, it gives you 5. If I were to run it again, here, 3, 4, you get 5. 10, 10, you get 14.142. 30, 40, you get 50. Okay. And so by just changing this in one place here, all of these times where my code was using it, all of them are now faster. Because undoubtedly the Hypot function is faster. It might not be, but it probably is. There's a lot of really smart people that write the standard library functions. Or in the case of, actually the standard library on here, there's one full-time guy. His name is Marshall. I've met him. He's a really cool dude. But people will spend a lot of time optimizing these things. There's probably some sort of mathy way of doing this involving logarithms and bit shifting and like, I don't know, what else. I'm actually kind of curious now about how Hypot's implemented. But it may or may not be faster. But if nothing else, it's cleaner. Right? It's easier to read. So, one way or the other. So, CI and CN, yeah, they kind of suck. C++, I've been trying to propose a readlib for standardization to be added to the C++ standard, and basically right now they don't want to add anything to the standard. That's what it amounts to. And people don't think that consoles are used anymore, which is an odd take. Are you able to make your own library? Sure, yeah. And I've released it on GitHub and stuff, and so there's a whole 30 people around the country using it. Around the world. Okay, so anyhow. So you can have a function that takes no parameters, returns nothing, that's fine. And so 31, 32. Yeah, I'll post the link on here. Read. So if you want the source code to that, there you go. 27, sorry. I overestimated my popularity. 27 whole people have started. Or maybe some people haven't started. I don't know. So anyway, you just download that file. And you include that file, and then it works. That's it. So you just include wherever you put it. I put it in the public directory. You include it with double quotes. And then you've got readlib. So, strength in numbers. Yeah. Okay. So you can also have a function that returns a value and takes no parameters. So that would also work. If you want to do this. And so the difference between this function Yoda and this function banana is something that confuses the hell out of a lot of CSI 40 students. Confuses the hell out of a lot of CSI 40 students. Like, they just don't see the difference between Yoda and banana. Say Yoda looks like a wrinkled up rotten banana. I don't know. No, but like, do you see the difference here? Like, Yoda is doing a cout call. Cout means print to the screen. Okay? It's not returning any value. It's printing to the screen. The Hypot of this and this is this. Banana is returning a value. It's like a function call. You call the function and then it passes back a value in the code. It doesn't print anything to the screen. If I replace these Yoda calls with banana calls, it's a brand new sentence that has never been spoken before. The heck? Do I have caps lock on? 4S, thank you. Banana. There we go. 3, 4. Look. 3, 4. It doesn't print the output. Do you see that? It's because Yoda prints to the screen. This one does not have a cout statement. Cout is print to the screen. Nowhere within banana do I have a cout statement. I mean, I guess technically There's like one hidden in here, but you know what I mean. Like there's no cout statement to print the result. Instead, what it's doing is it's returning a value. And so it's returning a value, and what am I doing with the value that comes out of banana? I'm squeezing the banana, and a number is coming out of it. Oh, this should not be an integer, by the way. This should be a double. All right. What am I doing with the return value from banana? It's returning a value. I'm calling it. It's doing all this mathematical computations, and it returns back to main. What am I doing with it? Returning the value is just like storing or holding value. It is providing, it's as if banana, like if I typed in 3 and 4, it is as if I had typed in 5, like that. Which is valid C++, by the way. If I run banana and type 3, return, 4, return, that is as if I had written code that wrote 5, semicolon. What's the problem with that? What am I doing with the number 5? What happens to it? Does it get output to the screen? Is this Python? No. What happens to the number 5 here? What happens to the return value of Python? Banana. Nothing. Absolutely nothing. That's valid C++. It just doesn't do anything. Yep. That's why it's printing nothing to the screen. You're just returning 5. It's like, all right, cool. Good times. So if you want to do something with it, you need to do something like this, like int 5. You know, these are doubles actually. So double. Do I have an x already? Nope. Good. Double x equals banana. So now I'm capturing the return value. All right, so if x is less than 10, you know, I can do one thing. And if it's greater or equal to 10, I can do another thing. You understand? So banana is passing back a value to me, and I have to capture it. I have to catch it. It's like playing catch. Like main calls into banana, it comes up here, it does some stuff, does some fancy math, and then banana throws back the ball saying, the answer is 5. And if you don't have anything here, it's like the ball drops on the field. It's like watching Little League. Have you guys ever seen kids play baseball? It's really terrible. You know what I'm talking about? Like, have you watched, like, especially like young kids play baseball? Like, do you know what I'm talking about? Like T-ball, or like not even, like maybe a couple years after T-ball. Used to ref for kids soccer. I saw the catcher right now get hit by the bat. It's like you hit the ball, the guy's running to first base, and then the third baseman picks up the ball and throws it to first base, and it flies past first base, and the guy keeps running to second, the first baseman runs over, picks up the ball, throws it to third base, flies past him, the runner goes to third base, third baseman picks up the ball, tries chasing after him, the guy runs home and gets a home run off what should have been, an out, right? That's what you're doing here with banana. You're just throwing the ball, and it's just dropping to the ground. You're doing nothing with it. It is not productive. You're wasting everybody's time. So you need to do something like this. Double x equals banana. Now I'm catching it, right? So main calls into banana, and sometimes you pass it a value. Like sometimes you're going to pass values to things, you know? So it's like you throw a ball to banana, and then it does its thing. Computation, and then it returns a value back out. So it's throwing the ball back out, you catch it, and now I can do things with it. If the return value is less than 10, do one thing, otherwise do another thing. And this comment is no longer true. This is no longer the first line of the program that runs. This is now the first line of the program that runs. There we go. You guys understand? So that's how flow of control works with a function. Like main, you start on the first line of main and you just go down to the bottom. And if you ever get a function call, it pauses main, it goes up into the function, does its thing, and then main can pass things to banana or whatever the function is, and banana can pass things back, and it's like playing catch. And you don't want to drop the ball, right? Like if you have a function here that takes a value, you don't want to not pass a value, or you don't want to pass it two values. If it's asking for a value, you pass it an int. Yeah, it's quite exciting though to watch young kids play baseball, because you can easily have scores of like 40 or 50 points. you keep hitting the ball goes 4 feet, you get a home run off of it. It's very exciting. It's a lot more exciting than Major League Baseball. Strikeout. Yeah. Every once in a while, somebody gets on base. Like, oh, maybe something's going to happen. Nope, 3 outs. Yeah. Okay, so so you can have functions that take no parameters but return something. You can have functions that take no parameters and return nothing. Functions that take a parameter and return something. All the combinations are possible. All the combinations are possible. So, so the final thing we're going to talk about today are string variables, and this will get you ready for your next homework assignment. Next homework assignment is called Hack the Mainframe. It's based on a board game called Mastermind. Also the name of the song by Deltron 3030. So Mastermind is a board game like this. And what you do is one person has a secret password and the other person is trying to guess it. And if you have the right color but in the wrong place, you give them a white pin. If they have the right color in the right place, you give them a red pin. So this one they got a red and a white because they got one in the right place and they got one that's the right color but in the wrong place. And so they sit there and they guess different patterns, and then eventually they get them all right. Hopefully. If not, the person down here wins. So this is basically what you're going to be doing, except having it look like a 1980s hacker movie. Okay. And so in order to do that, oh no! Oh no! Oh no! Oh, oof! Was that you? Was that you recording that, Tim? Oh, it's Reddit. Okay, yeah. No, it's jeez. What was the batter thinking? Like, did they pitch it and he just like? So for those of you at home, the catcher runs out and the batter whacks him right in the back. American martial arts right there. That's what it is. Okay, anyway. So we are going to talk about strings and string functions now. This is pretty important stuff. So if we have a string s, it's set equal to hello world. This is a thing. We can obviously cout it. We can cout the 4th letter of it. That. Hello world, and the 4th letter is L. 0, 1, 2, 3, L, right? And we all know that already. But we're going to work on converting to and from strings and integers now. So we've got an integer x that's set equal to 420. A lot of people will try to do this. String s is equal to x, especially this makes sense if you do JavaScript or Python, but C++ does not allow for this. You cannot convert between a string and an integer naturally. That said, C++ will allow you to set a string equal to 0. And it shouldn't. It shouldn't. Actually, one of the things I want to propose to the standards committee is just the special case not allow this. Because I can't think of any example where this is actually something you want to have happen. If you try running this code, it explodes. You're thinking, oh, because a lot of students will do that. Like, I'll initialize x to be 0. I'll initialize a float to be 0. I'll initialize a string to be 0. And then it explodes. It crashes your program if you do this. And it won't make sense why it does that until you learn pointers. But this is unfortunately legal when this is not, and it will never work. It will never do what you expect. It will crash your code, guaranteed. And it really annoys me that the language works that way, actually. So you cannot convert directly between an integer and a string. If you want to do that, you have to call toString. So toString, that will convert the x into a string. And so now we've got the string, so it's not 420 the number, it is now 420 the word. Okay, it is the letters 420, double quotes on both sides. And so you can do things like s plus equals s. And that will append yep. So now we got 420, 420. Okay. this is not a number anymore. If this was a number, it would be 840, right? If you add an integer to itself, 420 plus 420 is 840. If it's a string, it does string concatenation. Okay, so this is now a string. It's not an integer. Okay. What should you initialize a string to? Nothing. Strings are not primitives. They do not need to be initialized. They will initialize themselves. Only primitives have issues with initialization, but if you want, you can do that. Okay. You can initialize it to empty string if you want. If you don't, it initializes itself to empty string. Okay, so that will do string appending. If you want to append a letter to it, s dot pushback will allow you to attach a letter to it. So then we got 420C, 420C. So we attach C to the end of 420, and then we attach it to itself. And then what if we, instead of doing that, that's fine. What if we did s dot at 2, which is a 0 digit. Let's change that to a 9. So 0th digit, 1's digit, 2's digit, that's going to be changed to a 9, so this is going to be 429. So it's 429C, 429C, cool. Now let's say we want to convert this back into an integer. So x is equal to string to integer. This is the learning point for today. String to integer conversion. And this is integer to string conversion. This will turn 429C, 429C into the number 429. Why doesn't it, well, maybe I should output X. So why doesn't it convert the whole thing? Well, the way that it works is when you try converting a string into an integer using stoi, string to integer, it converts one letter at a time, and once it hits something that is not a digit, it stops. So it goes 4, 2, 9, okay, it's 429, C, okay, we're done. And it converts it to be 429. If, however, the first digit is a letter, like rather than that, let's reverse the string. Reverse s dot begin, s dot end. If we reverse the string, this is going to turn, this turns 420C into CO24. Okay, so reverse will flip a string around. So if you have radar, for example, it flips around, it becomes radar. If you have Bill, it turns into lib. You have Kearney, it turns into Yerknab. So reverse switches all the letters in the string, so they go backwards. And so this will turn 420C into CO24. And if we try running this, you will crash. You will crash. It throws an exception and terminates the program. And the reason for that is because if you try converting C924, if you try converting that into a number, the first digit's not a number, so it stops immediately. It throws an exception. It says, you done goofed. You messed up. So be careful of that. So this will throw if the first letter is, first char is a letter. It's a non-digit, to be precise. Okay. So that is that. It's basically what you need to know for the assignment. So basically, for the assignment, the user is going to type in a 6-digit password, and then, passing a string to a function. So let's do int count chars in strings. We're going to take in a string s and a char c. So it's going to count how many times the char c appears in S. And do you think, what kind of loop should we use for this? Should we use a range-based for loop? Should we use a regular for loop? Should we use a while loop? Should we use a do while loop? What loop should we use? We're going to count how many times C appears in S. What would you guys like to see? Regular for loop or range-based for loop? Those are the two main options. Basically, you're going to work the same way. It's just a regular for loop's more typing. Range-based, cool. All right. So, so for every character x in S, if x is equal to C, we need a variable, int count equals 0. So this is going to hold how many times we've seen that letter in the string. So for every letter in the string, if that letter matches the character passed in here, then count plus plus, and then we are going to return. Okay, so if we type in B, and we pass that in as the string, we pass in B as the character, it's going to say 1. It's going to go through the string, find how many B's are in the string. Okay, so yeah, let's not do that right now, because that'll crash us. Instead, let's see out. There are, what is it? Count chars and strings. Count chars and string in the string S. We're going to say how many characters. Zeros in the string. So there are 0 zeros in the string. Oh, well, that's fair. I changed it, didn't I? Okay, well, let's try that again. There are how many 9s in the string? There are 2 9s in the string C924, C924. Okay, so this function here passes the string, and it passes the character we're searching for. And there is a standard library function that does this, but I just thought it'd be useful to show you guys from scratch. There's a better way of doing this, by the way. This thing should technically be passed in as const string reference, but we haven't learned that yet, so don't worry about it. Just pull that out for now. So we're passing in a string, we're passing a character. We're going to hunt through the string for every character in that string. If that character matches the thing we're looking for, we increment the number of characters we've seen, and then we return the number of characters we've seen. So this is going to be very useful for your mastermind project. And the mastermind project is, of course, called Hack the Mainframe. And so Hack the Mainframe is going to have a hacking theme to it. It's like you're trying to hack in war games or something like this. The user types in, so let's say 76166 is the correct code. The user types in like 0112. It says you got 1 correct and in the right place, because the 1, right? The 1's correct in the right place. And then you have 1 digit that is correct but in the wrong position, and it's that 1 there. And so that's all you have to do. So basically, given a number, you convert it to a string, and then you see if the user gets it right or not. If they type in the right string, correct, you win. If they do 20 guesses and get them all wrong, then they lose. And nuclear war takes place. Okay. So that's it for today. This is it for today. Start cracking on it now. See how much of it you can do now. And get stuck now. And then on Friday, you can ask good questions about it. There's a tendency that I'm well aware of to wait until the last minute to do something. And if you do that, though, you're not going to be able to get unstuck. So you need to start an assignment early, get working on it early, so you know when you're going to get stuck early. If you wait to the last minute, you just might pull down a 0. So you need to at least put in an hour, I would say, and then you would know to a certain extent if you can do it or not. You know, or if it's just like beyond you and you need help. Okay. When is it due? In a week. Basically, all of my homework assignments are due in a week unless I say otherwise. So sometimes, like for a really trivial assignment, I might give 5 days. Pretty much everything, and it's for hard assignments, I might give 9 days. But for this assignment and for most assignments, it's a week. So you get a week, and it's plenty of time to do it. You should be fine. We're going to work on it on Friday in lab, and we're also going to be learning more about functions in lab on Friday. So that is it for today, guys. Thank you very much for coming out, and I will see y'all on Friday. Peace out.